Okay, first and foremost, let me wish you a very, very happy new year, not like 2020 full of pandemics and all that, right? Now, as you know that probably this is the first time I'm seeing you. Anyway, last but not the least, we can start it up this way. I am teaching mathematics, as you all know, right? Okay, and then I have given out certain kind of notes already, and more than 75% is already over. So you will have to take the trouble to go through the note, and I have already told you that if there is any hitch or any difficulty to understand the note, you can always contact me so that I can clarify that. So for today, I want to start with algebra, and algebra, I'll tell you, I hope one thing, whenever you attend the class, especially this type of class, you should be there with the pen and paper. So whatever I say or I write, you try to write it down correctly and then immediately, and that will help you quite a lot. And at the end of the lecture, if there is any hitch, you can note it down and send it to me, all right? Or send it to Sir Jeff here, so that he can give it to me and I can explain it once again, okay? So first of all, in algebra, since we have finished some of the portions like partial fraction, imaginary quantities, determinants, and matrices, you see, those are very, very important chapters. And today I'm going to start with this thing. What do you call it? Combinatorics. Combinatorics, it is written like this. Combinatorics. Well, in the book, I don't think you'll find it combinatorics. Actually, combinatorics is divided into two large sections. One is a permutation, Permutation, that is permutation, and then the other part is known as combination. What is it? Combination, combination. Now both of them, they sound alike, but then there is a difference, a mathematical difference. Now these are dealing in arrangement of distinct objects, okay? Now I would like to ask you one thing. What did you have in the breakfast? Now you might say that I've had a banana, a bread, butter, and milk. Well, if you tell me I took milk, banana, butter, and bread, it is the same thing. Is that right? There is no difference. If I put the one which I said first in the last place, and if I said the middle one, say bread and butter, if I put it in the first and in the last, it doesn't matter. Is that right? Now that kind of arrangement of objects, which does not signify anything different from what you said earlier, that comes under combination. All right? Combination. Well, selection of engineers. There may be many engineers. I want to select two of them. So any two of them will do. So it doesn't matter which one I take. So that also comes under combination. For that matter, the selection of students. Suppose you want to play cricket and now I want to select about 11 of you. So I can select any 11 of you from there. So that is known as combination, right? Okay. Now you might be waiting to see what is the difference between combination and permutation. You see that when it comes to the figure or digits or alphabets, right? The arrangement will certainly matter. For example, I write, there are three alphabets, P-A-T, right? Okay, P-A-T, it has got a meaning, certainly different meaning. But if I want to change the placement, suppose I write A-P-T, I'm using the same alphabet, but it becomes a different word. The first word is pat, P-A-T, pat. Suppose you have done something good, so somebody patted on your back, so that is pat. But what is apt? A-P-T, apt. A-P-T, apt. Suppose I want to pass, if I am to make myself apt to pass the examination, then I must study. So that is a different meaning altogether. Or for that matter, I arrange the same letter in different way, T-A-P. T-A-P, tap, from where the water flows. Is that right? Okay. This is the case when the alphabets are there, and the different placing of the alphabets will carry different meaning. Of course, there may be some of the words which may not carry any meaning. So, say I say PTA, I'm using the same word, but it doesn't carry any meaning. But still it is a word without meaning. Okay, so I hope you could find the difference between combination and the permutation. Okay, right. Now let us come to the digits, like 1, 2, 3, 0, etc. Okay, so let's say 2, 1, 3. I'm using 2, 1, and 3. These are different digits. Okay, but then if I change the order, if I just replace one by the other, then it will be a different number. This is 213, as you all know. Now, if I write 2 in the same place, I can interchange 3 and 1. It becomes 231, which is entirely different from 213, right? Or 123, right? This is different, although we are using the same digits, but then it carries a different meaning. So, in nutshell, in short, you know that permutation comprises of those arrangements which will carry different meanings, right? Say 132 or 321 or 312, etc. Right? Okay. Now I would like you to note down the formula for permutation and combination. Permutation usually is denoted by the letter P, and combination by the first letter of the word, that is C. Okay. Now I shall write this one. You take it down, please. NPR. NPR. Let me write it a little bigger. NPR. Now, if you come across this kind of symbol, NPR, or in your examination they are using a different symbol, like this one, PNR. So, this will carry the same meaning. Please take it as a note that this will carry the same meaning. The meaning is what? The permutation of n different objects taking r at a time. Suppose you have got 10 different objects and you want to take 5 at a time out of those 10. But you said, no, I would like to take all. That means out of 10, you can take all 10, right? Or But can you take 11 out of 10? No. So out of n, you can take r. So obviously n is always greater than or equal to r. Or in other words, r is always less than or equal to n. Right? So this one is expressed as, now you please note down, n factorial. I'll come to this. What is n factorial? Okay. Then n minus r factorial. So this is the formula for permutation of n different things taken r at a time. So you have noted that, right? Okay. And secondly, this is number one. Number two, let's come to the combination. Combination also will be written as NCR, that is combination of n different things taken r at a time, or they might write CNR, but it will be n factorial on the top, okay? Same. But then there will be some difference in the denominator, that is r factorial and n minus r factorial. Please note that down and then try to remember them. NPR or PNR is n factorial divided by n minus r factorial, and NCR or CNR is defined as n factorial over r factorial multiplied by n minus r factorial. Okay. Now, what is the factorial all about? Now, factorial word has got the word factor in that, right? Factor. It is, what is that? Factorial. Now, its symbol, there are two. One is like L and another with the exclamation mark, which I've used here, right? So you can use either this or this one, but this will be used as prefix, whereas this will be used as suffix here. You see that? After the things, r factorial, n factorial. But the same thing I would be able to write. In place of n factorial, I can write factorial n. Okay? So, nothing to get confusion all about. So, what is factorial n? Factorial n are the factors starting from unity, 1 multiplied to 2 multiplied to 3 multiplied to 4 till you reach n. N is any positive number. So before reaching 3, what do you get? You get, before reaching 4, you get 3. That is 1 less than 4. Before reaching 3, you get what? 2, which is 1 less than 3. So ultimately you will be getting n, because it is factorial n or n factorial or n factorial. Okay? So before reaching n, you will be getting some factor which is 1 less than n. And before reaching n minus 1, you will get some digit which is 1 less than n minus 1. That will be n minus 2. Right? So in between there are other digits, say 5, 6, 7, 8, 9, 10, etc., etc. Or you would be able to write this on the other way around also, like n into n minus 1 into n minus 2, and then it is in the descending order, right? So that is the significance, or that is the meaning of n factorial. Now let's come to some concrete example, like 10 factorial. What do you understand by 10 factorial? Now you will be able to tell me. 10 factorial will be 1 into 2 into 3 into up to 10, right? So this is what? 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10, right? Okay. Now my question is, does 10 factorial contain 5 factorial? Answer is yes. Why? Because where is 5 factorial? 1 into 2 into 3 into 4 into 5. If you take up to here, this will be what? This will be regarded as 5 factorial. So it could be written as 5 factorial multiplied to the rest. Rest will be 6 into 7 into 8 into 9 into 10. Is that right? Okay. If you like, for your convenience and for your tackling the sum, you would be able to write it as 9 factorial into 10 also. Because 9 factorial will contain all the factors starting from 1 to 9. Is that right? So 9 factorial into 10. Or you may be able to write it as 7 factorial multiplied to what? After 7 follows 8 into 9 into 10. Is that right? Okay. So that is it. Okay, now where are this used? Now you got to clarify yourself with this thing, with the concept. Suppose I write, I hope you can see this one, I write 1 upon 3 factorial plus 1 upon 4 factorial will be equal to what? Now 3 factorial and 4 factorial are not just 3 and 4. If it is 3 and 4, the LCM will be 12, right? But here I shall not write 12 factorial. Why? Because by your knowledge of that one, 4 factorial contains 3 factorial. Is that right? Since 4 factorial contains 3 factorial, the LCM will be what? 4 factorial. LCM, that is least common multiple. That is 4 factorial is the least common multiple which can be divided by 3 factorial as well as 4 factorial. Now 4 factorial, as you know, 4 factorial can be, you just try to recall, it can be written as 3 factorial into 4. So 3 factorial will cancel with 3 factorial, you will be getting 4. So 4 plus 4 factorial divides 4 factorial just once. So 1 into 1 will be 1. So this will be 5 upon 4 factorial will be the answer. Is that right? Now at times I have seen that there were questions like this one. Find the value of x when, let's try to write it as a question. Find x when say 1 upon 9 factorial, I am just cooking up, plus 1 upon 10 factorial is equal to x upon 10 factorial, right? Now this is an equation, as you know that there is a sign of equality here, 1 upon 9 factorial plus 1 upon 10 factorial is equal to x upon 10 factorial. Now how are you going to solve it out? First of all, you try to combine this. Now when you try to combine this, what will happen? Tell me. This will give you, what is the LCM? Of course, that's 9 factorial is very much within 10 factorial. So I can write the LCM to be 10 factorial. And 9 factorial divides 10 factorial 10 times. Because 9 factorial, this is 10 factorial, can be written as what? 9 factorial into 10. So 9 factorial cancels away with 9 factorial, you will be left with 10. 10 multiplied to 1 is 10. Plus 10 factorial divides 10 factorial once. 1 into 1 is 1, equal to x by 10 factorial. Now how are you going to approach further? Answer is very simple. This identical denominators are there, so we can cancel them away, right? So 10 plus 1 is 11. 11 is equal to x. So therefore, what is the value of x? X is equal to 11. Okay? All right. So that is it. That is about clarifying the concept or the idea of factors. Now let's come to the permutation. Okay. Now I'm going to give you a little idea about this permutation, and then I'll start with one exercise, all right? Say how many numbers can be formed by using the following digits. Hopefully you're writing following digits. Say 1, 3, 7, 8 and 9. Okay, 8 and 9. I want to make things simpler. So 1 is different from 3, is different from 7, is different from 8, and it is different from 9, right? So how many digits are there? 1, 2, 3, 4, and 5. So since this is a question, so it has to be followed by a sign of interrogation, as you know, right? Okay. Then the total number of numbers. You want to use all the numbers, 1, 2, 3, 4, 5 digits, and you want to use all of them. Now for that matter, the total number, let me use this one for number of digits, is equal to, is it 5? 1, 2, 3, 4, 5. So the question is how many numbers can be formed? So that means you are going to use all of them, right? So the numbers to be taken, and remember before I forget to tell you, 0 factorial is always equal to 1. Please note down. The proof is given in every book. It is a simple proof. So 0 factorial is always equal to 1. Well, that's a fictitious thing. So 1 factorial is also equal to 1, whereas 2 factorial will be 1 into 2, 3 factorial will be 1 into 2 into 3. Is that right? So number of digits to be used is also 5 to form the numbers. So therefore, the total number, right, that can be formed will be how much? You have got 5, it will be 5p5. Or you would be able to write this one as p5, 5 also. When you are using this, don't use this. And when you are using this, you don't need to use this. Okay, now apply the relation that I gave you. What was the relation? That is P n r is what? Can you remember? It is n factorial divided by n minus r factorial. Is that right? So it will be what? Our n is also 5 and our r is also 5. So it will be 5 factorial over 5 minus 5 factorial. So that will be 5 factorial will be 1 into 2 into 3 into 4 into 5 divided by 0 factorial. But 0 factorial is 1, right? So you got to multiply and see how many numbers will be there. 1 2s are 2, 2 3s are 6, 6 4s are 24, 24 5s are 120, I think, right? So 120. So if you are going to use all these digits, the total number of numbers that you can form will be 120. Suppose how many numbers can be formed by using, well, you take down this one as a question to be done by you, okay, as an exercise. How many numbers can be formed by using 3 of the following digits 1, 3, 7, 8 and 9? That means you can take at the most only 3. Either you take 1, 3, 7 or 1, 7, 8 or 1, 8, 9 or 9, 7, 8 or 9, 3, 7 or 9, 8, 1, etc. Right? So the answer will be what? Total number of digits in that case will be how much? It will be 5 because 1, 3, 7, 8 and 9, there are 5. And number of digits to be used will be 3, right? Now you can find your answer. So the total numbers that can be formed will be 5p, 3, or you can write that one. So if you are using this, as I told you, don't use this, okay? Then the rest, I shall not do it. So it will be what? On the top, it will be 5 factorial. At the bottom, it will be 5 minus 3 factorial. That will be 2 factorial. 2. So what will be the answer? Tell me. If you can work it out mentally, I think it's 60. Okay? Right. I think that's all for today. We should not bite more than what we can chew, is not it? So for today, that much will be enough, and then we'll be doing out something more about permutation as well as combination later when we meet again. All right? So that's all. Take care and bye-bye.